Welcome, this is Algebra 2, Semester 1, Day 2, Stretching, Shrinking, and Reflecting of Parent Functions. So, in your notes today in class, you should have done page 2 on the transformations that occur with a reflection. That should have been done in class. Actually, that wouldn't be done in class because that'll be done in class tomorrow. Tonight we're talking about reflections. So, turn to your attached graphs that we looked at before in the last video. And now you're going to go to number 1. On number 1, you notice the only thing that we've done to the parent function is we've put a negative out in front. So basically, you're taking all of your x values that you got and you're multiplying them by a -1. So you can just take these up here, multiply them by a -1. Or you can take these as you plug them in and multiply them by a -1. So -3 times -1 is 3, 2, 1, 0, -1, -2, -3. Okay? So, stop the video, go ahead and graph that. Under description, when we put a negative out in front, that's called a reflection. And what we mean by that is that that negative causes this graph to be reflected over this x-axis. So it's just as if I took this parent graph and I put a mirror right here where my pencil is on the x-axis, and I flipped this line down here and this line up here. And that's how we get the reflection. Anytime you put a negative in front, that's what it's going to do, is cause a reflection. Absolute value reflection. Well, if we look at the parent graph, we should already picture what's going to happen when we put the negative out front. Go ahead and pause the video and then come back on and see if you have it correct. And for description, it is a reflection because of that negative out front. Your quadratic graph, same thing, we have a reflection. Go ahead and pause the video and see if you get it right when you do this. And again, the description is reflection. Your last graph is the cubic transformation graph. Again, if you can picture it, you're flipping or you're reflecting over the x-axis. So you would have a reflection of that down here and this up there. Let's get the points and make sure that that is what we get. Pause the video, make sure that you get the same points as I do. And there's the reflection graph. Okay, the next thing that you're asked to do, it says on day 2 that we are to do the number 2 and number 3 graphs on those pages as well. So we'll go ahead and do that. So the number 2 and the number 3, let's see what happens here. First, let me get my pages in order with yours. Number 2, we have a 1/2 out in front. So 1/2 of a -3 is a -1.5. 1/2 of -2 is -1. 1/2 of -1 is -1/2. Half of 0 is 0. Half of 1 is 1/2. Half of 2 is 1. Half of 3 is 1.5. So go ahead and plot those points and then turn the video back on. The next graph, what we're doing is we're multiplying each of these values by 2. So we're making them twice as big. And when we look at these two graphs close together, this one had a value of a 1/2 in front, and you notice how it caused the tilt to come down this way. This one had a 2 in front, and you notice the tilt got real steep. What we call that in math, we actually look at the distance from the tip of the arrow out here to the x-axis, and here we see, wow, that's a lot bigger than here. Compared to the parent graph, when it's 1/2, it comes closer to the x-axis. So we call that being shrunk, or it shrinks to the x-axis by a 1/2. Comes half as close as the parent function to the x-axis. When it pulls up higher, we call that a stretch, and we say that it's stretching by a factor of 2. Because it's twice as far from the x-axis. A lot of things depend upon that x-axis you're beginning to notice. Let's go to the next one. 1/2 of our absolute value. Well, the absolute value of -3 was 3. 1/2 of that is 1.5. 1/2 of 2 is 1. 1/2 of 1 is 1/2. 0, 1/2, 1, and 1.5. Over here to the 2, it's going to get twice as high, so 6, 4, 2, 0, 2, 4, 6. So we go ahead and we graph these points. So again, we notice that the distance from the line down to the x-axis over here compared to the parent graph, this one has shrunk. It shrinks by 1/2. Here it's twice as high, so we call that a stretch by 2. Transformations, no matter what shape of graph it is, they do the same things. The number has the same action. So here you can guess we're going to see a shrink by 1/2. Go ahead and fill in your values. And it shrinks by 1/2. And here we're multiplying the 2 out front, so we'd expect it to stretch by 2. Let's see if it does. When you plug these in, by the way, you square the -3 before you multiply by 2. So -3 times -3 is 9 times 2 is 18. So now we see a U that appears to be real skinny when it gets stretched. I have a lot of students that'll mark that as being skinny, but it doesn't make sense when it's on a linear graph. So get used to the terminology that it's stretched by 2. 2 being the number that we have out front. Cubic again. We're going to see it shrink to the x-axis. So you can see it's just slightly wider than that one before, which is a shrink by 1/2. And now on this one, it is going to stretch by 2. So it's going to be a little bit challenging to graph. We know that it's stretching by 2. At 0, we're at 0. At 1, we're at 2. -1, we're at -2. But now they go off the graph. They're so steep and narrow. Okay, and that's your stretch. Again, that was on the cubic function, cubic transformation page. Okay, going back up to your notes. This is page 1 of your notes. Sorry, I bumped the camera. This is page 1 of your notes. This was actually on the front page. It's page 10, but it's page 1. This would be numeral page 1, but it's actually page 2. We did the graphs. Now it says, tomorrow in class, you're going to come in and you're going to do page 2, and you'll be in small groups to do that. And page 3, we're just looking at the commonalities there. Then you will go ahead and you'll do page 4 and page 5. And then we'll have an activity on stretching and shrinking and matching graphs and domain and ranges. So that's the end of today's video. Thank you. Nice job.